All right, let's get right to it. I'm going to go through everything here pretty quickly. You should check with your key, which should be down in the, I think down here somewhere is where I'll try and put it. It's also on the School Fusion website. I'm going to go through all of this, and if you have trouble with any particular problem, just zoom forward to that one. So, distributive property is where we have the thing outside the parentheses. Oops. And it distributes to what's inside the parentheses. And so an example of that would be something, oops, sorry, that should be 2x. And I'm writing it this way just because a lot of times everybody can't see it when it's backwards. And so if it appears backwards on the test, I want you to be able to recognize it. The commutative property of addition basically says that if I have a plus 3, that is going to be the same as 3 plus a. Order does not matter when you add. The associative property of multiplication says that, hey, when I multiply, I can regroup things as I see fit. And so the difference between commutative and associative is, in the commutative property, it's things changing order, where in the associative property, what we're changing is what is inside the parentheses. The multiplicative identity, now I think I used this on the sheet, which is 1 times cosine squared theta equals cosine squared theta. And you're probably asking yourself, what the heck is cosine squared theta? And the point is, it doesn't matter. 1 times that is going to be itself. That's the whole point of the multiplicative identity property. Even if I don't know what I'm multiplying by 1, if I multiply by 1, it does not change. And the addition property of equality says that, hey, if I start off with a true statement and I do something crazy, like add 2 to both sides, the statement stays true. So those are the first 5. Number 6, solve this problem for W. So I'm going to try and get W alone. So first thing I need to do is get rid of this 4 on the bottom. So I'm going to multiply both sides by 4. 4's cancel here, and I'll get 3W plus P equals 4R. Then I'm going to subtract P from both sides, and I'll get 3W, P minus P is 0, equals 4R minus P. And then to finish it off, I will divide both sides by 3, and I will get W equals 4R minus P over 3. I can't reduce. 4 doesn't go into 3, does not go into 4, and 3 does not go into P. Once again, I'm going through this quickly. If you need to see it again, rewind it. All right, for this one, solve for y. So I'm going to subtract 9x from both sides. And I always write my term with the variable first, like this, so that it's in the right form so if I ever had to take a test where I have to graph, it's already in this form from Algebra 1, slope-intercept form. So what I'm going to do here is then I'm going to divide both sides by 3. That cancels, and I'll get y equals. And what I'll do is I will split this up into 2 pieces. And then I will reduce the fractions. For number 8, so we're going to just plug a in. So this is going to be negative 12 times the absolute value of 10 times negative 2 minus 12. So I have to do the absolute value first. That's the first thing I have to get rid of. So I have to finish everything inside. So negative 2 times 10 is negative 20 minus 12, which is negative 12 times and negative 20 minus 12 is negative 32. And the absolute value of negative 32 is 32. And so my final answer is going to be negative 384. So that was number 8. Number 9 over here, I'm going to sub in, and I will get 2 times 4 times negative 1/4 minus 1 minus 8 times negative 1/4 plus 5, absolute value. So this is going to be 2 times negative 1 minus 1, here, so we don't get confused about what's or ones. Oh, sorry, that's all in there. Minus the absolute value of negative 2 plus 5. Or 2 times the absolute value of negative 2 minus the absolute value of 3. So the absolute value of negative 2 is 2, and the absolute value of 3 is 3, and so that's 4 minus 3, and your answer is 1. All right, the additive inverse and the multiplicative inverse. So the additive inverse is what would I add to 5/3 to make it go away? And that would be negative 5/3, because negative, remember, anything plus its opposite is 0. So if I give you something and ask for the additive inverse, you're just going to do that. The multiplicative inverse of 5/3 is 3/5, because the multiplicative inverse says that anything times its reciprocal is 1, and the reciprocal of 5/3 is 3/5. All right, solve each equation and graph the solution. So because this is an absolute value problem, what we need to do here is absolute value is isolated, so I'm going to create 2 different equations. 6x minus 24 is greater than 12, and 6x minus 24 is less than negative 12. Because remember, absolute value means that what's in here has to be greater than 12. So what's in here could either be greater than 12, or what's in here could be less than negative 12. So, and they solve the same. Add 24 to both sides, you'll get 6x is greater than 36. Divide both sides by 6, and you'll get x is greater than 6. Same thing, add 24 to both sides, and I'll get 6x is less than 12. Divide both sides by 6, and I'll get x is less than 2. So 2, 4, 6. Oh, by the way, on the test, please don't go 6, 4, 2. That's not how number lines go. 2, 4, 6. Open circle at 6, shading up. Open circle at 2, shading down. So the interval is, and this is the one that we didn't go over, I didn't go over in the review, so hopefully you're watching this, is that it's negative infinity to 2 and 6 to infinity. And it's the union of those two. For number 13, this one won't take long. You subtract 5 from both sides, and you get the absolute value of 5x is less than negative 3. Now remember, absolute value always spits out a positive number. And if a positive number cannot be less than negative 3. So the answer is no solution. interval is easy. It's the empty set. Graph's already done. All right. Remember that when we do these, if we're solving, we have to isolate the absolute value first. So just if you get confused, think about solving this, where this represents what's the absolute value. We'd add 4 to both sides, and we divide both sides by 5. And we're going to do the same thing right here. Is I'm going to add 4 to both sides, and I'll get 5 times the absolute value of 2r plus 3 equals 5. Then I'm going to divide both sides by 5. This cancels, and I'll get the absolute value of 2r plus 3 equals 1. Now at this point, I'm not now absolute value is isolated. So I'm going to get either 2r plus 3 equals 1 or 2r plus 3 equals negative 1. So once you have your two equations, then you solve each one. So I will subtract 3, and I'll get 2r equals negative 2. Divide both sides by 2, and I'll get r equals negative 1. Or I'll get 2r equals negative 4. Divide both sides by 2, and I'll get r equals negative 2. And we should plug them back in, but if you plug both of these back in, they both work. And so my solutions are negative 2, negative. And there's my graph. My solution set is negative 2 comma negative 1. Because it's a set, it's not an interval. Right, for number 15, the absolute value is isolated, so I can create my two equations. 3x minus 12 is less than 8. And 3x minus 12 is greater than or equal to negative 8. So then we're going to solve each one individually. I'll add 12 to both sides, and I'll get 3x is less than or equal to 20. Divide both sides by 3, and I'll get x is less than or equal to 20 over 3. If decimals really, fractions still freak you out, you can always change that to a decimal, which is 6.6 repeating. Over here, I'm going to add 12 to both sides, and I'll get 3x is greater than or equal to 4. Or x is greater than 1.3 repeating. And remember, this is absolute value less than, which means that it needs to get big, and we should expect the graph to look like a barbell. And because it's less than or equal to, the circles will be filled in. So I'll just put in a circle here at 1.3 repeating, put a circle here at 6.6 repeating. It's less than 6.6, but also greater than 1.33, which means I should be able to write this as a compound inequality. And the interval is 1.3 repeating to 6.6 repeating. And you can leave this in as fractions, I did on the key, but the interval is the same. Okay, so this is asking, okay, can we noodle through which one of the shapes we're going to get? So let's look at 16 and 17. We have the absolute value of something less than or equal to c. So remember, if absolute value is less than the number, we're going to get the barbell. But it's less than or equal to, so not only are we going to get the barbell, but we're going to get the barbell filled in. And we're going to be able to write it as a compound inequality. So, which one of these is a compound inequality? We'll see in DR, but if this is less than or equal to, it's going to have to be C and J. The next one, it's going in the opposite direction. Absolute value is bigger than the number. It doesn't have to go to the gym to work out. It can go cruising for chicks using its turn signals, using the tortured analogy we used in class. So, and it's going to be an OR statement. So this is going to be B, F. For number 20, it's once again absolute value, but it says that what it's C is negative. So we have absolute value of some number less than a negative number. Absolute value always spits out a positive number, so this is not possible. So this is no solution, and the graph will be empty. 22 and 23 is slightly different because that's an equals. So the only one it can possibly be is E, and the graph is just going to be the two dots like that. Now, even if we've been using process of elimination, we should know what we have left, but let's do it on the safe side. So absolute value less than, it's a barbell, no line underneath, so the barbells are open, and it's going to be written as a compound inequality, so it's D and H. All right, I apologize, there was a typo on the sheet. This parenthesis should be here. So once we have that, then we can do that. So how you do this? What changed from the first step to the second step? Well, they distributed the x, didn't they? So this is the distributive property. All right, between this step, okay, so between the second step and the third step, what changed? Well, they added in this -7 to both sides. So if we add something to both sides of a problem, what is that? Well, that's the additive property of equality. Between this step and this step, what changed? Oh, we changed what was in the parentheses over here. And changing parentheses is the associative property of addition. Between this step and this step, what changed? Well, we added 0. Well, and it didn't change. Well, that's the identity property of addition. Between this step and this step, what happened? Oh, we multiplied both sides by -1/2. That is the multiplication property of equality. And between this step and this step, we multiplied 1 by x. And it didn't change, so that's the identity property of multiplication. And if you have any questions after watching the video of any of these problems, bring them to class. Otherwise, I'll see you on Monday or Tuesday.